Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon and welcome to International Research Class. For this time, we will continue our programming to discuss the parameter of density function using the Markov chain Monte Carlo. We have discussed how to estimate the parameter of the GEV or generalized extreme value distribution. We have success to produce or create the R programming to solve the problem using the MCMC methods. Now we continue our program with using Markov chain Monte Carlo methods to estimate the parameter of the generalized logistic distribution. Based on the one research article, namely mathematical modeling for engineering problems with the title Power Bayesian Markov chain Monte Carlo for modeling extreme temperature in Sumatra Island using generalized extreme value and generalized logistic distribution. In this research article, there is the density function of GLO. You can check in the table 2. GLO is the generalized logistic. You can find the density function. You can find the cumulative and you can find the quantile function. Okay, and then we have discussed about the algorithm to use the MCMC to estimate the parameter. We have the X step here. The first one, initialize the chain theta 0. Okay, and then we try to create the pi star or equal to pi g minus 1 plus omega pi equal to normal with parameter 0 and 4. We accept pi star equal to pi g with the probability equal to minimum 1a, where a equal to posterior pi star given c g minus 1 kappa g minus 1 divide the posterior pi g minus 1 given c g minus 1 and kappa g minus 1. And then we try to produce the parameter of C star until we have the success to produce the parameter kappa. Okay, we have talked this algorithm in the first discussion about the how to use MCMC to solve the parameter for GEV. Now we continue for GLO with the same algorithm, of course, different in the density function. Okay, we try to open our R programming to solve the problem. Okay, we check our R programming. Okay, this is programming. This is programming to the generalized logistic. You can check in your home. The first one we try to make it to try to produce the program for the likelihood. The likelihood for the generalized logistic is leaks t power minus 2 exponent minus 1 minus e double multiplied by y and divide bb. There is y and there is bb. bb is mean 1 plus exponent minus y power 2 and y means minus e power minus 2 multiplied by logs w. Okay, w, this is for w. Okay, this is for the density or likelihood density for generalized X-ray value. And then we use the same program to Markov chain Monte Carlo. We use the same initial value and we use burning M for 30,000 Of course, we will result the circuit southern for parameter U, T, and E. Okay. And then we have the omega U. Okay. You remember omega U? Normal, which parameter 0 and 4. This is omega T, then omega E. Okay, this is one, the all programming, the Markov-Chain Monte Carlo to find the parameter U parameter, T parameter, and E parameter. Okay, we run our program, we try run our program, we come to the windows and the console. Okay, we find the data, Z. Okay, this is SAM's data. Z is mean the maximum temperature in one station in Indonesia in the 21 years. Okay, we caps lock, put the one Z, enter. This is the data. The data maximum temperature for the 21 years in the station one in this our research. Of course, after we have the Z or the data, we run our program for the generalized logistic. Okay, we run our program. Okay, we check in the console. Okay, our program is success to run the likelihood. After that, we run the program through the Markov-Chain Monte Carlo. Okay, this one gives the initial value, and then we run the whole program for the Mcmc. Okay, we run, and then we back to the console. We check here, and then we waiting for the program in the process. Okay, there is a one problem in the initial value. We try to change to become minus 0.1. Remember, if your program do not run, so it means your program is not wrong, but you must try to change the initial value. Okay, after we change initial value, we run again our program. Okay, we run again, and then we come to the console. We wait for the program. Maybe takes a long time, I think, because our program is run. Good programming, I think, not takes a long time. Okay, after that, we try checks what's the U parameter. Of course, we must have the 30,000 parameter U. Okay, this one. And then we have the 30,000 parameter for T. Okay, this one. And we must have the 30,000 for parameter E. Okay, this goes programming. So after we have the 30,000 for each parameter, we need the methods to choose the one, which one the best parameter. So we try plot the trace plot and the posterior density plot. Okay. This is the plot for the trace plot and then posterior density plot. Okay, good. We check our graphic. Okay, this one our graphic. You can check here. There is good the parameter success to convergence to the one value of the parameter, like the trace plot for the pi or the alpha. This is trace plot for the C, and this one for the kappa. The whole program success to give the 30,000 the problem. Okay, so after that, we check in the posterior density. In the maximum picture, you can check here is the fixed value for the parameter. Okay, you can check for the parameter alpha. This is in this area, of course, the fixed value problem. And then for parameter C, you can check this one is the maximum. So between 0 and 1, this one they call the C, and then they call the kappa between 0 and 0.5. So, of course, we need the real value, the fixed value. So from the 30,000 parameter, we try to use the median of the each parameter. Okay. For that why we use the median of the parameter. Okay, like this one, we use the median U for the fixed value of parameter U or alpha right here, and median T to text the real value or the fixed value for the parameter C run here, and the median E we use to take the fixed value for the parameter kappa run here. Okay, we check in the console. Okay, this one is the fixed value for the all parameter in the generalized logistic. Okay, for the everybody or for the our student, for the researchers who need the program, we try to open the slowly the program. You can adopt this program. You can use this program to solve your result problem, especially in the estimates parameter, the generalized logistic distribution. Okay, this one is a programming for the likelihood logistic distribution, and this one for the Mcmc parameter. This is initial value, and then this is burning 30,000 burning, and then this one for the initial value, and then this for omega u, omega t, omega e, or omega pi, omega c, and omega kappa, and this one the all program. Like this one, this is pi star equal to pi g minus 1 plus omega pi. This one is problem. And then this A is mean we have discussed. A is the posterior pi star given C G minus 1 kappa G minus 1 divide the posterior pi G minus 1 C minus 1 and kappa minus 1. This is for the parameter 2 or pi. This is parameter T for the C. This is parameter E for the kappa. Okay. I hope our program is very, very useful for you all in the home, and you are success to create, to make the result, the best result, the best result, the best result using our program. Okay, Radio Yendra International Research Class. See you again.